Imagine taking the entire mass of Mount Everest and crushing it into a space no larger than a raindrop. Now multiply that intensity by 1,000,000,000, and you might come close to the mind-bending density of a neutron star. These cosmic remnants are among the most extreme objects in the universe. Stellar corpses so dense that a single teaspoon of their material would weigh as much as all of humanity. But what truly happens inside these unimaginably compact objects? How does matter behave when crushed beyond anything we can recreate on Earth? The answers push the limits of physics itself. Neutron stars are born from catastrophe. When a massive star many times heavier than our Sun reaches the end of its life, it doesn't fade quietly. Instead, it explodes in a supernova, one of the most violent events in the cosmos. The outer layers are blasted into space in a brilliant flash visible across galaxies, while the core collapses inward at nearly a quarter the speed of light. If the remaining core is between 1 and 3 times the mass of the Sun, gravity doesn't stop until it has compressed all that matter into a sphere only about 12 miles across. At this point, atoms themselves can no longer exist. Electrons, normally orbiting at a safe distance from atomic nuclei, are forced into protons, transforming them into neutrons. The entire star becomes a seething ocean of nuclear particles, packed so tightly that it's essentially a single gigantic atomic nucleus, but one with the mass of a star. The surface of a neutron star is a place of impossible extremes. Gravity here is so strong that if you could stand on it, which you couldn't, because you'd be instantly flattened, you would weigh billions of times more than on Earth. Even light, which normally escapes effortlessly from stars, struggles to break free, bending and distorting under the immense gravitational pull. The thin outer crust, perhaps only a few centimeters thick, is made of iron nuclei squeezed into a rigid crystalline structure. But this is the only familiar part. As we descend deeper, the pressure becomes so overwhelming that even atomic nuclei shatter. Electrons and protons merge into neutrons, and the rules of ordinary matter no longer apply. Deeper inside, we enter a realm where physics becomes speculative. The neutrons, normally confined inside atomic nuclei, now exist in a free-flowing superfluid state. This isn't like any liquid we know. It has zero viscosity, meaning it flows without any friction at all. Some theories suggest that under these extreme conditions, the neutrons themselves might break apart into their fundamental components, quarks. If this happens, the core of the neutron star could become a quark gluon plasma, a state of matter that hasn't existed naturally since the first microseconds after the Big Bang. Even stranger, some models predict that a new form of matter could emerge, strange quark matter, where up, down, and strange quarks mix freely in an exotic, ultra-dense suit. But the weirdness doesn't stop there. Neutron stars spin at dizzying speeds, some rotating hundreds of times per second. These rapidly spinning neutron stars, called pulsars, emit beams of radiation from their magnetic poles. As they rotate, these beams sweep across space like a lighthouse, appearing to pulse when observed from Earth. The precision of these pulses is so exact that scientists have used them to test Einstein's theory of general relativity with incredible accuracy. The magnetic fields around neutron stars are another source of extreme physics. They can be 1 trillion times stronger than Earth's magnetic field, so powerful that they distort the very structure of atoms in their vicinity. If a neutron star with such a magnetic field came anywhere near our solar system, its influence would wreak havoc on electronic devices and even molecular bonds in living organisms. At the very center of a neutron star, conditions become so extreme that even our best theories struggle to describe what might be happening. Some physicists speculate that hyperons, exotic particles heavier than neutrons, might form under these pressures. Others suggest that the core might transition into a superconductor, where electrical currents flow without resistance. There's even a possibility that some neutron stars might contain small black holes at their centers, formed when the density crosses a critical threshold. The truth is, we simply don't know for sure. The pressures and densities inside a neutron star's core are beyond anything we can replicate in laboratories, meaning that these objects remain one of the great unsolved mysteries of astrophysics. Studying neutron stars isn't just about understanding these bizarre objects, it's about probing the fundamental laws of the universe. They serve as natural laboratories for testing physics under conditions we can't recreate on Earth. By observing their behavior, scientists can explore the nature of matter at extreme densities, the behavior of gravity in intense fields, and even the possible existence of new states of matter. Every new discovery about neutron stars brings us closer to answering some of the biggest questions in physics. What happens to matter when it's pushed beyond its breaking point? Are there forms of matter we haven't even imagined yet? The next time you look up at the night sky, consider this. Scattered throughout the galaxy are these incredible stellar remnants, spinning at unfathomable speeds, denting space and time around them, and hiding secrets about the very fabric of reality. Neutron stars remind us that the universe is far stranger and more wonderful than we often realize. They challenge our understanding, push the boundaries of science, and prove that even in death, stars can reveal some of the most profound truths about the cosmos.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.